Hi, myself Sanjeev. I will be talking about the power of small models, and specifically in machine learning. In recent years, the field of artificial intelligence (AI) has seen a massive surge in interest and investment, like large language model LLMs like OpenAI, GPT series, Google's Gemini have dominated headlines, showcasing their ability to generate human-like tests, translate languages, and perform a wide range of tasks with remarkable accuracy. However, alongside these massive models are quite revolutionary in underway emphasize the power of small models. The shift toward smaller, more efficient model is not just because of technical adjustment, but a fundamental rethinking of AI roles in society, industry, and technology. And and I will be and the evolution of AI from big to small. If I let me evolution of AI models, the early days of AI models were marked by relatively small models constrained by limited computational resources available at the time. AI computing power increased, so did the size, complexity of AI models. Researchers discovered that largest model could achieve higher accuracy, perform more complex tasks, leading to creation of massive neural networks with billions of parameters. However, this trend toward even large models has significant downside. The models require enormous amount of computational power, memory, energy. They are expensive to train and maintain, making them accessible only to select a few organizations with vast resources. Additionally, the environmental impact of training large model has raised ethical concerns about AI sustainability. And if I talk about uh, yeah, in response to these challenges, and researchers, practitioners are now tuning their attention back to the small models. The goal is to achieve high performance while minimizing resource requirement. This approach resolves optimizing model architecture, leverage pre-trained embedding, and using techniques like distillation, tuning to reduce model size without sacrificing the accuracy. The benefits of like small models, there are multiple benefits like efficiency and the speed. It's like one of the most obvious advantage of small model is their efficiency. Smaller model require less computational power, which translates to faster inference items, low operational cost. The efficiency is particularly important to real-time applications like chatbot, recommendation system, fraud detection, etc. For example, a small model deployed on a mobile device can provide instant response without relying on cloud-based servers. This reduces latency and enhances the user experience. In contrast, large models often require powerful GPUs, cloud infrastructure, leading to the higher cost and slower response time. If I talk about accessibility, smaller model democratize, democratize AI by making more accessible to individuals and organizations with limited resources instead of relying on expensive cloud services. So, small models can be deployed on edge devices like smartphones, IoT devices, embedded system. So, this opens up new possibilities for AI applications in remote area, developing countries, and industries with stringent cost constraints. For instance, healthcare provider in a rural area can use a small AI model on a portable device to diagnose medical condition without needing internet connection. Similarly, small model can enable smart home devices to function without sending data to cloud, improving their privacy and security. And if I talk about sustainability, the environmental impact of AI is growing concern. Training large model consumes vast amount of energy, contributing to carbon emission. In contrast, small models are more sustainable, requiring less energy for both training and interference. By prioritizing small models, the AI community can reduce its carbon footprint and promote more environmental responsible practices. And in last, customization and adaptability. Small models are easier to customize and adapt to specific tasks. Large models are often general purpose, require fine tunings to achieve optimal performance on specialized skills tasks. In contrast, small models can be designed from the ground up for particular use case, resulting in more efficient solution. For example, small model trained to detect defects in manufacturing processes can outperform a larger general purpose model by focusing on the specific patterns and anomalies relevant to that industry. So they're like different techniques for uh, building small models. So first one is like model pruning. Uh, it involves removing unnecessary parameters from model to reduce its size, complexity. This technique can be applied after a model has been trained, identifying, removing weight that have little impact on the model's output. Pruning not only reduces the size of the model but also improve interference speed and reduce memory usage. There are various pruning strategies, including magnitude pruning, structured pruning, and dynamic pruning. And then is knowledge distillation. Knowledge distillation is a technique where smaller model is student, where the larger model, that is pre-trained model, is like teacher. The model aims to replicate the teacher's behavior, capturing its knowledge in a more compact form. This approach allows smaller model to achieve performance levels comparable to larger models while maintaining efficiency. Distillation can be particularly effective in scenarios while deploying a large model is impractical. For example, model can be used to mobile application to provide high quality AI services without consuming excessive resources. Then is quantization, which reduces the precision of models weight and activations, typically from 32-bit floating point number to 8-bit integers. The reduction significantly decreases the model size and computational requirement without substantially affecting its accuracy. Quantized models are particularly well suited for deployment on edges devices where memory and processing power are limited. By reducing the model size, and quantization enables AI application to run efficiently on hardware constrained devices. And then the last is transfer learning, which involves using pre-trained models, that is teacher, as a starting point for a new task. Instead of training model from scratch, developers can leverage existing knowledge embedded in a pre-trained model and fine-tune it for specific applications. The approach is highly efficient as it reduces the amount of data and computational resources needed to train. The transfer learning is especially valuable for small models, enabling them to achieve high performance with minimal training. And if I talk about real world applications, then is we're gonna start with the mobile applications. So small models are ideal for the mobile applications where resources are limited and user expect fast responsive performance. Example include voice assistant, language translation apps, personalized recommendations. And if we talk about edge computing, refers to the processing data locally on device rather than relying on centralized cloud servers. Small models are essential for edge computing, enabling AI application to run on IoT devices, smart cameras, and other embedded systems. And if we talk about healthcare, small models can be deployed on portable device to provide diagnostic servers, monitor patient health, assist in medical decision making. These models can operate in remote areas without even internet connectivity, making healthcare kind of more accessible. And if we talk about finance, so in finance sector, small models can be used to fraud detection, risk assessment, personalized financial advice. Their efficiency and speed can make them suitable for real-time applications, while quick decision making is critical. And the last NLP, that is natural language processing. Small NLP models can be used for tasks like sentiment analysis, text summarization, language translation by optimizing model architecture, leveraging techniques like distillation. Developers can create efficient NLP solutions that run on a wide range of devices. And if we talk about future of small models, the future of AI lies in finding the right balance between the model size and performance, while large models will continue to play a role in advancing state of the art of AI. Small models are poised to become the backbone of practical real-world application. Emerging trends such as federated learning, edge AI, further underscore the importance of small models. Federated learning enables devices to collaboratively learn from shared data without transmitting it to the central server, enhancing privacy, security. Small models are crucial for implementing learning at scale. Moreover, enhancement in hardware such as AI accelerator chips are making it more easier to deploy small models on a wide range of devices. These innovations will further drive the adoption of small model across industries. So, in the conclusion, so the power of small model lies in their ability to deliver efficient, accessible, sustainable AI solution. So they help across all the industries, providing it less can be more. That can be a less can be a more. Thank you.